On behalf of the Russell Sage Foundation, Alfred P. Sloan Foundation, and Princeton University, it's my pleasure to welcome you all back to the Summer Institute in Computational Social Science. Welcome to the people here in Princeton, welcome to the people at the partner locations, and welcome to everyone tuning in on the live stream. We're very lucky today that we have Brandon Stewart with us here today. So Brandon is an assistant professor in the sociology department, and his office is 2 doors down from mine, so I know for many, many reasons that this is going to be a great talk. I want to tell you a little bit about Brandon's research. So he's doing really path-breaking research kind of at the intersection of social science and data science, particularly focused on text. He's affiliated with the Center for Statistics and Machine Learning at Princeton and also the Center for Digital Humanities. I think he might be one of the only faculty members involved in both. One of the things I love about Brandon's work is that in addition to addressing some of the core statistical problems that arise in working with text data, he also works very hard to address some of the core computational problems that arise. And so he's invested a lot of effort in producing great open source software called STM, which I think will implement many of the methods that you all hear about today, and it will implement them quickly. And for those of you who have developed open source packages, you know that that is not an easy thing to do. And so we're all very grateful for that. So in addition, though, to the statistical and the computational, he's also worked on some of what I would call the more theoretical or foundational problems that arise in working with text. So he has a paper thinking about what causal inference means with text data. And it turns out that's actually not really, it's partially a statistical question, it's partially a computational question, but it's partly a theoretical question. And so I love that his work spans all of these areas. And for that reason, I would highly recommend the book that he's working on, which will be available very soon. It will be called something like Text as Data, and it will be co-authored with Molly Roberts and Justin Grimmer. So with that background, it's now my pleasure to welcome Brandon Stewart.
Thank you. All right. Hi, everyone. Thank you for that lovely introduction. And also hi to everybody, at the partner sites. I did this 2 years ago when there were no partner sites. And I think it's pretty amazing that people actually, volunteered to run these partner sites and give this to everybody else as well. So anyway, I'm going to talk a little bit about topic models today. I'm going to focus on sort of a conceptual understanding of what we think these models are doing in social science, trying really to build in a theory of use. Chris has some amazing slides on the SICSS website that he gave last year that have a lot of the details of how you would go through and implement these things. And I recommend you sort of checking those out. I've also written some introductory materials that kind of step through use of various software packages. So those are available, but not exactly what I'm going to talk about here. Okay. So to start, I just want to frame with a contrast a little bit between big data and big analytics. So there's been this massive increase in unstructured text that's available to us. And this is for a lot of reasons, right? One is just that there are these kind of new social structures where communication is happening, email, Facebook, et cetera, et cetera. And then there's new and improved forms of data collection, right? So things like Matt has invented wiki surveys. People are doing increasing numbers of survey experiments, things where we're collecting text from people that we're soliciting. And then the third is just these massive digitization efforts, right? So Google Books trying to scan everything. Governments are increasingly digitizing all their records and putting them online. And what this means is that communities are now leaving digitized footprints in a way that they weren't before, which is really exciting if you're trying to do some social science, you're trying to understand those communities, because things that weren't previously visible to us now are. And text analysis is, broadly speaking, a tool that's going to help augment human effort, but importantly not replace human effort in accessing these increasingly large sets of data. So the good thing is that tools have been sort of advancing in parallel with the access to the data. And that's good because the text by itself is quite useless, right? It's available at a scale that we're not going to be able to carefully read and systematically analyze all of it. And so what we want to be able to do instead is carefully read and systematically analyze some of it, and then have that effort amplified up to the full large million document collection of text. And so to do this, we're going to import methods from a lot of different fields. And I think a bit of what I'm going to try to talk to you about today is the implications of doing that importing. And like, what does it mean when we take something out of a context in which it was designed and put it to a sort of different purpose? It's also the case that as we develop more methods, it's going to drive more data availability. So I worked on a project with a then law student at Yale Law on constitutional law and text. And we used this database from the Library of Congress called Chronicling America. And at the time that we wanted to use it, you could access these sort of individual newspaper pages that they had scanned from like the 1860s. And we went in and we wrote a scraper to try to like grab every single one of these because we wanted to do some like giant topic model type work. And eventually we just kind of went and asked them, and we were like, could you just like give us all of these things instead of having us go grab them one by one, because it's kind of irritating and it's hurting your website. And they were like, oh, like we just never thought someone would want all the OCR. Here, have several terabytes of data. And we were like, great. So there's this sense in which, like, as we show that we can do useful things with the text, there's more incentive for other actors to provide that to us, which I think is really exciting as well. I'll also pause here to just note that if people have questions while we're going, I hope you'll interrupt, or people on the live stream can ask via some Slack system that I don't understand, but I'm sure they will come. So it's important to think about what we're trying to do in text analysis. And so I'm going to posit that there are sort of three tasks here. So the first is discovery, right? This is the idea that we want to spark new concepts and explore the data to sort of think about things we hadn't before. And once we acknowledge that discovery is like an important part of the research process, we can develop methods to go about improving it. Unfortunately, I think the narrative in research right now is that ideas come to us, like, you know, the picture of, you know, where God is sort of placing this idea in Adam, right? Like, it's like that, right? It's just like a magical idea pops into our head. And that's not what science actually looks like, right? Science is iterative. Science ideas come from the data. And once we acknowledge that ideas aren't just things that come out of the brilliance of people, but are a process of work, we can develop methods that help us do that work. Importantly, though, that when you are taking a set of data and you're discovering something in it, you need different data to test that discovery. You can't discover and test on the same data. It's another sort of insight that comes out of formalizing this. So the second thing that we end up doing a lot of is measurement. Right? So we want to operationalize a concept and measure the phenomenon at scale. That could be something as simple as like measuring the sentiment of movie reviewers towards movies, but it could also be something much more complicated. And importantly, validation here is going to be really necessary to establish that we've captured the quantity that we really want to capture. So the third area is causal inference. And this is making an assessment of an effect of a counterfactual intervention. So what would have happened if? Right? And that's going to take slightly more nuanced assumptions than measurement. I've done some work with other collaborators, including Justin Grimmer, who I think is here tomorrow to talk to you guys about text as a treatment, so the intervention. Text is the outcome, the thing that you're measuring, and then text is a confounder, right? So a thing that affects selection into treatment, but also your outcome. And care is really needed in these settings to maintain the sort of usual causal inference assumptions. Okay, so I'm going to talk about kind of a couple of broad classes of methods. So the first are called supervised learning. It's a paradigm that comes out of machine learning. And so supervised learning is like pursuing a known goal. So the sort of workflow here is basically that a human comes in and annotates a subset of documents. That's right, says this movie review is positive, this one is negative. And then the algorithm trains on those annotations and learns to annotate the rest so that you can sort of take your effort on a few thousand documents and scale it to several millions relatively seamlessly. And we might think about this as sort of associated paradigmatically with quantitative research, right? It's a kind of thing where there's a kind of known target and we're learning to hit that target. A second class of methods are called unsupervised methods. And here, in a way that is maybe unfamiliar to some, the goal is to learn what the goal is, right? So the workflow is that an algorithm is going to go in and discover themes or patterns that exist in the text. And then the human's role is to go in and interpret those results. So note that these two strategies, it's not that one of them involves more human effort than the other, they're just different in where the human enters into the workflow and the kind of task that the human's doing. So unsupervised learning, I think the best analogy for this might be qualitative research, and particularly things like kind of ethnographic fieldwork for people that are familiar with that tradition, right? You're going into an environment, you are observing patterns, and you're trying to do some kind of meaning making around those patterns. And it's a very different form of research, I think, in some ways, than people who are used to quantitative work are comfortable with, right? So there's this element of which text analysis is a quantitative method that's fundamentally qualitative in many of its aspects. It's a kind of hard thing to get your head around at first, I think. So again, both of these strategies are amplifying human effort, but in different ways. And I'm going to focus today on the unsupervised methods. And the reason I'm going to do that is because books and papers in the social sciences have largely embraced this kind of unsupervised approach. So early works like Justin Grimmer's work on how senators portray themselves to constituents, Amy Catalinak's amazing work on how certain electoral reforms in Japan kind of changed the course of their foreign policy. And even in the digital humanities, where folks have looked at distant reading of many different novels trying to detect themes. All of these particular books, but also tons of other papers, including many that I've written, many that Chris has written, have taken on this kind of unsupervised approach. And all of these things are very different than the way that these models have been applied in computer science. And so I want to kind of take a beat to think about what it means to shift contexts. So in computer science and statistics, these methods were used as a way to summarize unstructured text, right? You're basically trying to do a form of information retrieval. Like, oh, you liked things about this, let me go find you some other documents that are like that. And what they're doing is they're using words that are inside the document to sort of infer roughly what its subject is about. And so we can think about this as a form of dimension reduction, right? Chris was just showing you just before this talk about the term document matrix, right? And the dimensionality on that can get really big, right? Vocabularies in reasonable text corpora are almost always in the thousands, often in the tens or hundreds of thousands. And so topic models are sort of a way to kind of shrink that dimensionality down to maybe 100 or something like that. So in the social sciences, though, we're doing something kind of different, right? So social scientists often are trying to use topics as a form of measurement. And particularly, they're not trying to pick out an individual document. They're interested in how observed information about those documents drives trends in the language, right? So do Republicans talk more about this issue than Democrats? Do women talk about this issue differently than men? And so what we want to do ultimately when we're social scientists is we want to tell a story, not just about what happened, but sort of why it happened and how it happened. That's the thing that ultimately tends to make social science, I think, different than data science or applications in computer science. And this means that we have to focus on different things. We have to really get in and focus on particularly validation, that when we say that this is a measure of economic content, that is actually what's going on, right? And that's going to take some reading, right? So these topic models are not a way to not read documents. They're a way to take your reading time and make the most effective use of it possible. Okay. So I'm going to pick up really quick with preprocessing. I'll just take a quick pause if there's any questions so far. Okay. So we are going to use a representation throughout topic models based on the bag of words that I think Chris just talked to you about, where we're essentially discarding word order. And so this is generally instantiated in this kind of document term matrix. I say at least conceptually because like the programming structures that live under this are often different, but this is the idea. And this is good at capturing subject matter of documents, but not necessarily nuance. All right? Because the idea is the reason topic models produce topics is really a function of how language works, right? We sort of reiterate over and over again the subject matter of what we're talking about when we speak, but we don't always necessarily like reiterate like elements of style, for example, in quite the same way. So he showed you the notion of preprocessing, but typically what we do is some form of this. We have some compound words that we break out. Maybe we take the phrase here, barrel of a gun, and we sort of treat it as one token. We get rid of some stop words, words like of, the, and, for. We drop them out. We hack off the ends of words, or we do some more nuanced form of lemmatization to map sort of various forms of a word back to their common root. So here we took political, we'll mop it down to polit, and grows back to grow. And then we can pop all of these things into a nice little matrix. So we end up with something like this, where you have a bunch of terms, and you have a bunch of documents, and you have some cells that say, this term showed up this many times in this document. So because we always talk about this recipe, and it's sort of a key part of the topic modeling workflow, I just want to like dig in a little bit on the way that the consensus has changed about this recipe over the last like 10 to 15 years. And the idea is that people really want there to be like some like raw, pure form of data. But the problem is that anything that we do to try to understand text is going to do like some amount of semantic violence to the richness of like what is there. And a lot of what we do, the way that we go through this process, is we take these things that were imported from 1990s computational linguistics, right? If you pull out classical textbooks, like for example by like Chris Manning, right? It's like, this is like what it tells you to do. It like runs through these steps. But there have been some great new papers that have pushed back in recent years. Some out of David Mimno's lab, most led by his graduate student, Alexandra Schofield, and then a recent piece in Political Science by Matt Denny and Arthur Sperling. And what these papers have sort of said is like, maybe we need to like rethink these recipes. Like maybe they're doing more harm than good. And particularly, what I like about the Schofield and Mimno papers is they point out that when you have a lot of documents, it is often not necessary to do these steps, and that they actually may do a bit more harm than good. And so the core point, the easy point, is that the preprocessing of text is pretty inevitable, but the choices are consequential, which is why I bring them up again, rather than just kind of saying, okay, you learned that already, like let's talk about other things. And I think this is really good, right? This is what a maturing field looks like. Computational social science is incredibly young still, but like this is what like mature fields do, is they go back and they say, let's take those basic assumptions and heuristics that we started with, and let's like rigorously investigate whether or not we still think those things are a good idea. An insight, at least for me in all of this, is that folk wisdom, rules of thumb, heuristics, like whatever you want to call it, those things are always a product of their time. So it's not that stemming is necessarily a bad idea. It's that for document collections that are the size that we had in the mid-1990s, stemming is pretty much always a good idea. Right? And I think anytime one of the things I find when I teach things to students is they always want like a rule of thumb, right? And I get it, right? We're at the end of the day, we're just like trying to get some science done, right? And so it's just like, just tell me what to do. And that's okay. I mean, heuristics are like how we function in the world. But I think the thing to remember is that heuristics are always specific to the context in which they were developed. And so the question that you have to be asking yourself over and over again is like, am I in a different universe than where that heuristic came from? And for those of us that are computational social scientists, like everyone in the room, right, we're probably all drawing from different disciplines all the time. So this is a pretty big point. So it's also worth noting, why do we do this stuff in the first place? I don't exactly know how Chris motivated this, but like it may have just been like, this is like a thing we do, right? That's like often how I end up teaching it. I want to give a take about why we do this, particularly for topic models. And I'm going to argue that there's two reasons. So the first is efficiency, right? So stemming is, in a statistical sense, a form of parameter tying, right? It's an equivalence assertion. It's saying, like, happy, happiness, happier. We want to give them all the same value in the model, right? And so we're going to force them all to be the same by just mapping them to the same token. And if you have enough data, you can learn nuances. You can learn the way that car means something different than cars. Or not, right? It might be that if what you're looking at is some kind of assessments of people's net worth, like cars starts to matter a lot compared to car, right? But in lots of settings, it'll basically be the same. And so the need for this arises from a pragmatically understandable focus on like relatively small corpora, which may be the kind that you want to use, in which case, this is great. The best answer, of course, here isn't to do stemming. It's if it's possible, it's to get more data. So the second reason is aesthetics, right? So people really like looking at lists of most probable words for a given topic. And things like stop words and unstem words make these lists harder to read. So arguably, this isn't a conceptual problem or a research problem. It's just a hard software problem. And for people in the room that like want to solve this hard software problem, I strongly encourage you to do it. Let's talk. But I just want to show you, so this is a plot that comes out of the structural topic models software, and it's a way that people often like to display topics, right? So basically what you're seeing here is the frequency of topics in the corpus, and you're seeing just 3 words that are sort of used, that those are the most probable words under that topic. And you might look at that and you might say, wow, those topics are garbage, right? They all just say the, of, or to. And it's like, okay, what have we really learned here? So it turns out that the, of, to are just really frequent words. And so no matter what you're talking about, you're going to probably use those words. And when you use a metric that we call FREX, that's available in the package, that prioritizes not just the frequency of a word under a topic, but also its exclusivity to that topic. You take these exact same topics, like literally the same topics, and you get labels that look like this, right? And so now you can see there's like some really sharply defined stuff going on here. Right? This is a corpus of political blogs that we like to use to illustrate things a lot. But you can see this these are like incredibly sharp topics. And it's not that the topic model has changed at all. This is the same topic model. It's just the way that we've chosen to present the results. So this is what I'm saying when I'm saying it's not that getting rid of these things was essential to getting a good topic model. It's just getting an essential to have like the picture that we typically make pop out nicely. So there's a practical issue here, which is that we have a lot of moving pieces in text analysis, and people just like want to be able to get some work done at the end of the day. And I totally understand that. So like we have to like make some choices about pre-processing. Okay, so let's actually talk about topic models. So the biggest topic model, the one that sort of kicked off the modern incarnation of topic models, is called Latent Dirichlet Allocation, which is a model developed by Dave Bly and Andrew Ng and Mike Jordan at Berkeley. And the original paper is 2001, but the one that gets cited all the time is this piece in JMLR in 2003. And so the idea here is that documents are going to exhibit each topic in some proportion. And every document is going to be a mixture over topics, and every topic is a mixture over words. So a topic is just like a bag of words. Though when you're generating some text from a topic, you just like reach into the bag and you just like pull out a word, right? Throw it on the page. And what the documents are going to represent is what fraction of the words came from each of the different topics. And so latent Dirichlet allocation, or LDA, estimates the distribution over words in each topic and the proportion of a document in each topic. So compared to like supervised things where you are setting a category and then the algorithm is classifying them, this is both inductively learning the categories and doing the classification at the same time. So the maintained assumptions here are we're still doing bag of words, and we have a sort of fixed number of topics that we're asking for. So in pictures, here's a way to think about it. You have a bunch of people, they all write some texts, and these texts discuss a few different topics each. And so what LDA is going to estimate is the distribution over words for each topic, right? So it might be that the most probable words are like estimator, data, analysis, variance, model, inference, and we're going to give that some label like statistics, right? So that's the human part is the part in color there where we're sort of making an interpretive judgment based on reading the documents and like looking at these words. And then we're going to go in, and then every document is going to be represented as like a proportional combination of these topics we've learned, which is really great because it means that you never have to have seen before a document that was both about politics and statistics to recognize this document, as long as you have other documents that are about politics and other documents that are about statistics. Right? So this is the power of this kind of mixed membership admixture structure, is you can get kind of unique combinations of things that maybe you only observe one of. The way that we set this up is there's a Bayesian model that we're going to learn some parameters to. I'm not going to go through that in depth, but this is what it looks like. It's sort of a combination of Dirichlet distributions and multinomial distributions. And the key thing is that given the topics in the corpus, given the topics in the document, every word is sort of generated independently. That's where you get that bag of words then coming from. So the core idea here is we want to discover some thematic content or quickly explore documents. We're going to do that by maximizing some objective function that comes from this probabilistic model, which I'm not going to go through in depth. And there's a bunch of ways to do this optimization. The three big ones are variational inference, collapse Gibbs sampling, and spectral methods. I could give like an entire lecture that was just about like each of these three things and like why they're cool and exciting. And so, you know, come talk to me if you like want to have that chat. But I'm not going to subject everybody here and around the world to that at this moment. So one way that I like thinking about this that comes from Hannah Wallach, as does this image, is thinking about LDA as like a statistical highlighter with a lot of colors, right? So here's an article, and you can see that there's a bunch of words highlighted, and the words that are highlighted in red come from this like red topic, right? And the idea is that every single word in the document is going to get a little highlight. Okay? And the representation we're going to use for the document is just like a little histogram of all of those colors, right? So to give you just kind of a sense of what we're doing. So why does this work, right? I think one of the things that people find slightly confounding about topic models is that you can give it a set of text, you can tell it nothing about the concept of baseball, for example, and it will just like pop out a topic about baseball. And the answer is pretty simple, right? So the answer is about co-occurrence and word co-occurrences in the document term matrix, right? So again, what we're trying to do is compress a matrix that looks like this, right? That has like documents and words. And what we're really doing to make that compression as efficient as possible is finding the cases where those columns look very similar to each other, and then just kind of like collapsing them together, right, at a very high level. So we're learning the idea when we learn a topic about baseball, that words like pitcher and catcher and base are all showing up together in the same documents a lot. And the way this gets instantiated in the probabilistic model is that the model wants to contain as few words as possible in each topic, but every document be represented with as few topics as possible. And those two things are in tension with each other, and it's what forces it to sort of come to an efficient solution. So LDA came about in the early aughts, and it turns out that there have been a few extensions proposed to LDA that you might consider. There's correlated topic models and dynamic topic models and hierarchical LDA, and in fact so many different models. And it turns out that like for a while this was just like how you got published in CS conferences, was like you would just like propose a new topic model for a different case. And that's cool if you're trying to get a job in computer science, but it's like maybe problematic if you're a social scientist trying to say like, how do I find something that's right for my problem? And so this was the situation that I felt like I was stepping into when I was doing my graduate work, right? So there's sort of different methods for every case. And there's a question here about like what's going on with all of these different extensions. So I'm going to argue that we can think about a lot of them, not all of them, as different forms of structured topic models, right? So to give you a few examples, there's the correlated topic model, which is due to Bly and Lafferty, which is basically encapsulating the idea that some topics are more likely to show up together than others, right? You're more likely to see a document that's both about economics and finance than about economics and cooking, right? So we want to encode that in the model. Sorry, I don't want to run out of time, so I'm going to jump past a couple of things here. The second is that the dynamic topic model. So this is capturing the idea that topics evolve over time, right? And so this was used by Dave Bly and John Lafferty to do some really interesting stuff looking at the evolution of science, right? So this is a figure from one of their papers where they're looking at the journal Science from the period 1880 to 2000. And you see this like evolution in the idea of a particular topic over time, right? Because the notion that they're capturing is that the discourse can shift, right? And it allows you to look at how like elements of a discourse shift within a particular topic, right? So the way that, for example, relativity rises and falls in the discussion of theoretical physics. There was a question, how do we do this with mics? Is there a procedure, or you can ask and I'll just repeat your question.
Yeah, I'm wondering how do you, like methodologically, how do you track topics over time? Like, do you do one big topic model of the whole corpus? Do you do one for each year? Can you repeat the question? Yeah, sure.
Great.
Turn the mic on. How do you do it?
So I can just repeat. So the idea was, how do you do this in practice? Do you do one model over the whole corpus, or do you do one model per year? Like, how do you track this? So I think this is a great question. This is the problem they were trying to solve. So like, let's say, what would happen if we did one model per year? So the problem is because the topics are being learned, there is no guarantee that the topics you would learn in 1890 would have any counterpart in 1900. Right, so that's kind of out. Like, we can't do that because if we did it in separate years, there's no way to track them over time because they don't necessarily connected to each other, right? So the next question is, well, like, maybe we just run one for the entire corpus. We just like run like LDA for the whole corpus. So the problem is that this topic expressed in 1880 may actually have nothing in common with the way it's expressed in 2000. What makes them the same topic is continuity over the years, right? It's that the 1880 and the 1890 versions are very similar to each other. And 1890 is similar to like 1900. But like by the end, it's just a whole different thing. And so if you ran LDA on the whole corpus, this stuff over here in 2000 would get put in a completely different topic than this stuff down here in 1880. And so what you end up doing is you fit a sort of Bayesian model that allows for the parameters of the topics to vary over time, but it forces that they vary smoothly. And so that's basically what's happening, is they're just kind of tweaking the construction of the model. So it gets run on the whole corpus, but the way the model is structured looks different. And this is a great question, actually, because like you can do this with like lots of different things, right? So this is about time, or at least about something that's kind of evolving smoothly, right? You could kind of imagine it over like a unidimensional space or something like that too, but the key is it's like one dimension and it's moving smoothly. But you could have a different setting. So like Justin Grimmer's setting, was that he wanted to measure attention that different senators allocate to different issues in their press releases. So now you have a different kind of structure, right? You have an authorial structure. We know that different authors are going to talk about different profiles of issues, and we want to learn that profile. And so we're stuck in that same tension where we could run one topic model across all the authors, but that wouldn't be quite satisfying. But if we ran a different topic model for each author, that also wouldn't be satisfying. And so we have to capture the structure of our corpus. And so the problem is so this is where we are in 2010, right? And so the problem is what happens then when someone comes and they say, hey, well, I have authors and time, and both of those things are important to me. Well, then you're sort of out of luck unless you're going to sort of write a whole new model yourself. And so this was the idea behind the structural topic model. So it's latent Dirichlet allocation plus this contextual information. And particularly, it's going to think about contextual information in two ways. One that can affect the topic prevalence, or the frequency with which something is discussed, right? So this is the idea that Hillary Clinton talks more about these issues than Joe Biden, right? And so the other way we can think about it is topical content, right? That is that they're discussing the same thing but in a different way. So this is the idea that in 1880, when the journal talks about devices, right, they talk about it really differently than in 2000. And so including this context really helps improve the model. It gives you more accurate estimation, but also, importantly for us, better qualitative interpretability. So to go back to our cartoon depiction, imagine now you have a lot of people, they're discussing some topics. What STM is going to do to that LDA formula is it's going to allow, for example, let's say the words in each topic to vary by some characteristics of the individual, like gender. Right? And so it might be, for example, that when talking about statistics, let's say men use the word data with much higher frequency, and women use the word inference with much higher frequency, but other words at about the same rate. Right? So now we've captured something about the way that the discourse differs between these different groups. And then the other option is that we could allow topic proportions to vary by some kind of grouping, maybe author, maybe time, maybe some just arbitrary groups A and B. Okay, so to give a sense of how this plays out in practice, what's going to happen is that the user is going to specify a number of topics. This is often called K, just by the letter we tend to use to represent this. And then we're going to have some standard data from topic models. So we're going to have a bunch of documents that are going to be collections of tokens. And every token is going to be an entry in a dictionary of vocabulary size D. And so we're just going to have a matrix, that term document matrix that Chris was showing you before, that's the number of documents by the number of words. So STM is going to add on top of that some additional data. So there's going to be some covariates X that affect the topic prevalence, so the frequency with which a topic is discussed. That could be the author, that could be the time, that could be the publication, venue, could be a lot of things. And then we're going to have a distinct set of groups that's going to say what topical content profile are these people speaking from. Then there's going to be all the normal latent variables that you get. You get the proportion for each document assigned to each topic. And you get the content of the topics themselves, so the probability of drawing a word conditional on a topic. And for those who have a statistical or mathematical background, I'll just note that what's really going on here, and in topic models in general, is that we're just creating a low rank approximation to this matrix I'm calling W tilde, which is just the expected counts of words in a document. That intuition doesn't help you, don't worry about it, not important, but for some people it's oh, that's what's happening. So the structural topic model is changing this up a little bit by changing first the prior on the document topic matrix, and we're going to do this with a little regression, basically. We're going to say that there's a little regression that explains your ex-ante likelihood of talking about something. And then we're going to have a different little regression that's going to describe how you talk about that something. And that little piece is going to have this look of a log linear model, where basically we think about a topic as some baseline distribution, right? Some words that people just use in general, right? A deviation from that captures what you are talking about, the topic. A deviation from that captures the particular community that you are coming from. And a deviation that captures the interaction of those things. So how your community talks about that particular issue. Right? So you might imagine, for example, there's some baseline distribution. There's the topic of finance, let's say. There's the fact that you are a Republican, and Republicans use some words more than others. And then there's some interaction between how Republicans talk about finance. Okay. So I want to just note that like LDA, STM is a probabilistic model, and the way that we're going to learn this is just like we're going to go in and estimate some parameters. Again, this is a thing that I'm more than happy to talk about at length, but I'm not going to do so much here, except to say that we're doing Bayesian estimation with variational inference, and that, in fact, one of the things that matters enormously in different topic model implementations is how you initialize the process. Right? And that is because these optimization problems are incredibly hard, and the solution you get depends on the starting values you use. So one of the things that I really think makes STM work almost as much or perhaps more than the covariate information is the way that we choose to initialize the model. We use this spectral method of moments estimator, but it tends to get you very good solutions. Again, all the complication aside, we're still just using word co-occurrences to figure out what the topics are. All the covariates are doing is help structure that information. So it's saying, for example, maybe this document contains these word co-occurrences, but we know you, this author, used these other words in these other documents. And so let's borrow some of that information when we're thinking about the one document. What's nice about the STM is that it's general to lots of kinds of corpus structure, right? So it's not just about authors or just about time. And in the STM package in R, we tried to make this really easy to do, right? The goal is to allow you to customize a topic model of your choosing. So we have a complete workflow in the package. You can take raw texts and you can run them all the way through producing figures that can go in papers. And there's a nice little regression style syntax formula that you can use. So here, for example, we're going to allow topic prevalence to be affected by the newspaper the story was published in and some smooth function of when it was published. And so it just kind of looks like, for those who are familiar with R, just looks like a little regression. There's lots of functions in the package for summarization and visualization and checking, and there's a vignette online that just runs you through a complete example and illustrates all the functions. Chris has a really nice example that draws some from the vignette, but also gives some nice short explanations of things that you can run through as well. And the important thing is you can do this with your data, and I hope you will. This is the fun, exciting part about doing software, is people take your stuff and they use it to do things you would never have imagined doing. Okay, so let me just, the last little bit is I just want to talk about some of the extra bits that have been tacked onto STM, and also talk a little bit about some applications. So one of the things that we tried to do is make auxiliary things to help you. It's important when you are designing software, for people in the room that are planning to do that at some point, that you make the workflow that you want people to have as easy to do as possible. Right? That people aren't going to do things unless it's simple. And so if you think someone ought to do something, initialize their model well, you have to make it the easiest thing to do. And one of the things that I would like people to be able to do with text analysis is be transparent about their results and read their documents and allow others to read their documents. And so we created this package called the STM browser. that basically will make a little website for you that creates this little browser where you can look at different topics and different metadata, and you can just click on each point. Each point here is a document, and then you can go read it. Right? I've been working on a different set that allows you to explore different aggregations of topics. It's called Trellis. It is up right now. It's still in beta. If it's a thing you'd want to explore, let me know. But basically, it's ways of thinking about how your sets of topics are organized. One of the really cool things is Karsten Schwemmer, who is an alum of this camp from last year, created this really cool package called STM Insights that I had nothing to do with. He just went and did it, and it was awesome. And my understanding, he's also running one of the partner sites. So hi, thanks for doing this. But it's basically a GUI that you can go in and explore the relationships between your variables, when a blog post was published, moderated by some other variable, and you can look at how it affects the probability of talking about a topic. And this is why I think this kind of thing is important, is this is the essence of, I think, what most people are using STM for, right? It's to make these statements about how the trends in a discourse are occurring generally over time, but also, over different groups. STM has a nice GitHub page, and you can go and you can explore. There's a little website that one of the things I like about it is that we drop up applications that this has been used for. So it's been used in quite a few papers at this point, but we just keep a running list. If you end up writing a paper using STM, let us know when it comes out, and I'll add it to the list, oftentimes at a little bit of a lag, depending on how behind I am on email. But the point is as a user, it means you can kind of then go and just see, what is it that people have done with this software and how they thought about it. One of the other cool things is that Julia Silge, this great data scientist, has written some nice examples of using this with tidy text. So I think Chris was showing you tidy text before. If you want to use tidy text with STM, you can go check out her stuff. She's made lots of nice little visualizations, and also just has a kind of cute example with the Sherlock Holmes TV show. So if you would rather see that than political blogs, to this blog post you can go. So again, to draw it back to the beginning, I think that people want these models to sort of do different things. And we've tried to run them through their paces in lots of different applications. So for example, in cases like discovery, so imagine, for example, that you're teaching a massive online course, right? If you have 50 people in your course, you might very carefully read course evaluations. I have talked to some people that incomprehensibly to me do not even read the 50, although I guess they can be kind of depressing and mean. But if you are at a giant scale, right, if you have 10,000 people in your class, you're not going to be able to read all of the course evaluations. And so it turns out things like topic models are great for that. You sort of discover what are the themes that people are saying about the course, and then you can read examples from each of those themes, such that you get a flavor for what people believe overall, or what kind of feedback they're giving. I've done some work with Molly Roberts about propaganda in China, where we wanted to understand what are all the things that are being talked about in Chinese newspapers, and what are the cases where the government is sort of directing newspapers to reprint sort of things from Xinhua, which is the national news service. And here's a case where you can't enumerate all the topics that are covered in a newspaper. But what we can do is learn a giant topic model on millions of documents and get a flavor for what are all the different things that are being discussed. And then finally, I sort of started with measurement, right? So if you want to make a claim, like we did, for example, in this paper, about how people engage across partisan differences in online classrooms, you need a measure of engagement, right? And this is the kind of thing that can be a basis for doing that kind of measurement. We've also done some stuff on open-ended survey responses where you have an experiment, you prime people with some kind of thing, and then you want to see how they write. And then the last sort of application I'll just mention very briefly is that Justin Grimmer and Molly Roberts and our two amazing graduate students, Naoki Agami and Christian Fong, did some work on causal inference using text and trying to think about, like, what does it mean to have topics in a topic model be like a treatment or like an intervention or an outcome. And it turns out there's some real subtleties to it. And so if you're sort of interested in doing this work, I recommend checking out this paper. So I think there's some really exciting emerging opportunities for text analysis in the social sciences. But one of the things that I've tried to give you a feel for here is that as we import techniques from other places, we have to be very cognizant about how we're changing the meaning of what we're doing. And one of the ways is to adapt methods that are fit for the context that we're in. So in the context of STM, we took this LDA model and some of the other variants that had been developed, and we sort of tried to make a version that worked for social scientists by making it easy for them to leverage the structure they knew about their corpus and make it easy to sort of make plots and figures that did the kind of things they wanted to do. There's a lot of other great packages for running the LDA model in R. I'll call out in particular Mallet, which is an extraordinarily well-built implementation of LDA that I'd sort of recommend if you're getting into it. And if you have a truly phenomenally large corpus, Text2Vec has a really nice implementation of an algorithm called Warp LDA that is incredibly blazingly fast. And so if you have, millions and millions and millions of documents, you might want to look there. The current implementation of STM will work pretty well up to maybe 1 million documents. And that's kind of starting to push it, but high hundreds of thousands. We're working on things to extend it further, but it's taking some time. We obviously skipped over a bunch of important details, but be sure to read more in this area and go try out the software today and play around with it. And so I'll just throw this up here and then I'll take some questions.
We've got a few questions from the live stream. They're 2 quick ones that I think maybe we can anticipate some of the group questions. One is, how do you determine the value of K? And the other is, what do you do with short texts? So, but I'm gonna guess you can point people to stuff quickly while I.
Yeah. So do you want me to just do this real quick? Okay. So let me do the short text one. So the core information topic models is about word co-occurrences, right? So if we take the limit of an incredibly short text, it's 1 word, right? We have no information to work with, and that is not great. So then the question is well, what do we do in the space of Twitter, right? Well, so to get a measure of what a tweet is about is difficult. At a corpus level, what is all of Twitter talking about? The short text on Twitter are actually fine, right? Because if you think about the opposite end of an incredibly long text, like a novel, the bag of words assumption means that you're treating the word on the first page and the word on the last page as the same as 2 words that are next to each other. And that's obviously kind of crazy, right? So the thing that's nice about tweets is actually that you know that these words go together in the context because the document is so short. But at the end of the day, to learn things about that one tweet, you just don't have very much to go on, right? Because all you have is a few instances of data. So things like the structural topic model can help with that because it can borrow information from other places. So say other tweets from the same person, right? By putting that into the structural topic model, you sort of allow yourself to share some information. But it is going to be the case that it's very difficult to do inferences on short documents like that. So in practice, what a lot of people do, if they can, is they aggregate over a bunch of tweets. But whether or not that's a good idea really, really depends on what you are trying to do with Twitter. So in terms of setting K, so there's lots of different questions about this always. And the question that people often want to ask is, what's the right answer? So if we believed the generative model, with a real model of language, the right answer would be relatively easy to find with model-based statistics. So you would go in and you would do something like maximize the Halbert log likelihood. And we have a nice function in STM called search K that will show you all of these model-based statistics. However, we don't believe this is a real model of language. And so I think the right way to think about K is that the right K is what is going to work for your purpose, right? It is a level of granularity of the text, not an underlying, a level of granularity of the summary you want, not an underlying property of the texts themselves, right? And so for your case, it might be that you want a high-level summary, a pretty coarse summary with like 50 topics or 10 topics. But somebody else might want like 200 topics because they're trying to study something more fine-grained. So I think human evaluation, human validation is the right way to go. There's a nice kind of articulation of this and more nuanced discussion of it in this piece that I wrote with Justin Grimmer called Text as Data, Promise and Pitfalls of Automated Content Analysis for Political Text. I don't know, it was a long time ago. But it's in Political Analysis in 2013, and we talk about this issue a bunch.
Thanks for your talk. I really like it.
Oh, thank you.
Thinking about applying the results of topical modeling to causal inference, like using it as the covariance in the matching. I know you have the paper about it. But I'm thinking about because most of the computer science model are based on some strong assumptions underlying the data. So there might be some dimensions that are orthogonal to the representation we have learned. So when we are really using them as covariates, there might be something that is missing and we don't even know what they are. So when we want to draw a causal inference, then maybe the treatment effect, the estimated treatment effect may be still very different from the twos. So I'm thinking about how we can partially address this concern.
Yeah, this is great. So to catch people up to folks, so the paper that he's referencing is a paper I wrote with Rich Nielsen and Molly Roberts. And the core idea in that paper is that if you want to match text together, matching in the statistical sense, where you're trying to find treatment and control units that are comparable up to the point where they were treated, then what you can do is you can run a topic model, you can pair things up by topics, and then you can include some information about the propensity to treatment, like a propensity score type model. And show how this can all be jointly estimated and talk about it. So you're totally right. We could be missing something. And in some cases, the confounding is not going to be capturable by things like topics or things that use the topic document term matrix. The way we talk about it in the paper covers kind of two things. One, you want human validation on this, right? So the advantage of doing matching is that you can look at pairs of documents and you can make an assessment using your expertise about whether or not there's some systematic confounding here, right? The thing that's hard about matching in like a job training study is all you know about the people that were trained is what's in that row of your data set. What's going on in the text though is you have this rich thing that you can read, and you can make an assessment whether or not it has picked up the nuance that it needs to pick up. The other way of thinking about it is that you can use measures to check balance, to sort of evaluate how close these things are that don't depend on the word order. So that do depend on word order, that don't depend on the topic model assumptions. So for example, we use string kernels, which are sort of a word order preserving metric of distance that to sort of evaluate how close the pairs are. But I think you're totally right. In lots of problems, it is going to be the case that these types of models are just too coarse to capture what you need to capture to get the confounding. And in any case, it's probably going to be the case that some confounding is left over. We're just trying to drive that bias in our sort of naive estimate down as much as humanly possible.
We have time for about 2 more questions.
Amazing talk.
So you.
My research has been dealing a lot with tracking the topic change of an event. So time is a very important factor I have to consider. So you mentioned about dynamic topic modeling and structural topic modeling. I wonder which one is better when I have time as the variable, because it seems like both work, but I just wonder what is the weakness or the strength for both of the methods.
Great. So if what you are interested in is the way that the words in the topic evolve over time, like so the way that the topic is talked about is changing, if that's your primary interest, you want the dynamic topic model. And the reason is because it is capturing this kind of smoothness component, right? So it's basically saying that this has to be more similar to this than it is to the one in like 1910, okay? And so the structural topic model is just saying there are discrete groups that talk about a thing differently, but they're not ordered. So, so if you want that topical content component, you want the dynamic topic model. If you are in a situation where you think the way that the topic is talked about isn't changing, it's just that the actual amount that it's being talked about is changing, you probably want the structural topic model because you have a lot more flexibility in how you model that change. So the dynamic topic model basically does one thing because it's kind of like a one-off solution that just happens to be quite good. The structural topic model, you can build in something that, for example, allows sharp discontinuous changes in the discourse, or maybe it enforces smoothness, or maybe it like combines those two. And you do that by just kind of like messing with the regression a little bit. So we can talk more maybe offline about your particular case, but that's the way I would think about it broadly.
Hi, thanks. Really enjoyed the talk. I have a more general question, which is, could you talk a bit about the advantages of topic modeling and these probabilistic approaches compared to other forms of dimensionality reduction that often do similar things? I'm thinking particularly of latent semantic analysis, where you just run a singular value decomposition on your Word document matrix, and it gives you these kind of also nice, somewhat interpretable topics.
Totally. That's a great question. So latent semantic analysis has some enormous virtues, right? So as he was saying, basically what's happening there is that you have a term document matrix. Often it's a weighted term document matrix, like weighted by like term frequency by inverse document frequency, sort of prioritizes mid-frequency words. And then you run an SVD, which is just like a matrix decomposition, and you get some things. So what's great about it is that it's very stable in the sense that, like, if you resample the documents, you're going to get something very similar, and the optimization problem is really easy because it's like an eigen composition that we really understand how to do. The downside is that topic models have this simplex constraint, right? So the loadings on a document have to be non-negative and sum to 1 if they're proportions. And in a singular value decomposition, you get values that are like negative and stuff. And so then the question is like, what does that mean? And in practice, what it often means actually is that the outer edges of the dimension actually have very different meanings. When you go very positive, it ends up meaning one thing. When you go very negative, it means something completely different. And that's because that's like an efficient way of reducing the dimension, but it doesn't lead to much interpretability. The other problem is that because there's no prior on the document loading, very short documents can be extraordinarily noisy. The regularization that comes out of these Bayesian models tends to be very effective for individual document level loadings. So if what you want is just like a broad sense of what's going on in a corpus, if you don't care about the individual document loadings, it actually might just be good because it's just going to be fast for one thing. But I tend to prefer topic models because I do like those proportions, and I do often really care about the document loadings themselves.
Thank you.
All right. Unfortunately, we're out of time. We do have Brandon here locally for one-on-one meetings, and maybe he would be so kind to answer some questions during our coffee break.
Totally.
There's still a few more, I think. So please join me. This has just been so fantastic.
Oh, thank you.
It's so great to have the actual author of the passage.
Thanks.